আমি শুরু করব?
Yes, sir.
Okay.
Sir.
Good afternoon. I give my sincere thanks to the organizer of this faculty development program for inviting me. This is my second session. I will try to give some information about parametric and non-parametric testing problems to you for solving your research problems through R. Actually, I will give some hands-on training of R on parametric and non-parametric testing in this session. I also give some information, theoretical information, a practical scenario where you will use parametric and non-parametric testing. I want that all participants try to do our course with me. Like yesterday, when I will ask some questions that you will raise your hands. During screen sharing, I am not able to check the chat box. What is statistics? Statistics is neither really a science nor a branch of mathematics. It is perhaps best considered as a meta-science for dealing with data collection, analysis, and interpretation. As such, its scope is enormous and it provides much guiding insight in many branches of science, business. At first, we thanks to Professor P.C. Mohalnavish for introducing statistics in our nation. Statistics is the science of collecting, organizing, analyzing, interpreting, and presenting data. This is basically old definition. A statistics is a single measure used to summarize a sample data set. For example, the average height of students in this group. A statistician is an expert with at least a master's degree in mathematics or statistics or a trained professional in a related field. Statistics is a tool for creating new understanding from a set of numbers. Statistics is a science of getting informed decisions. This is the flowchart of taxonomy of statistics. Statistical methods are divided in two broad ways: descriptive methods and inferential methods. In this session, we concentrate in this part inferential methods. Actually, not whole inference method, only testing problem. Inferential methods, there are two parts. One is estimation and another is testing of hypothesis. Today, we concentrate on testing of hypothesis only. What is a statistical inference? Is to draw conclusions about the population on the basis of information available in the sample, which has been drawn from the population by a random sampling technique or procedure. Main problem in real life is that we need some information about the characteristic of a population, maybe height, maybe weight, maybe any other things. But it is not possible for us to evaluate measures of that studied characteristics for whole population. It is very much time consuming, costly, and it is next to impossible for large population. For this reason, census is the complete enumeration process. Census happen on 10 years gap because it is not possible for our large country. Census is done in every year. So 10 years gap. This is the main problem in real life. Statistics basically helps get the information of the population on the basis of information available in the sample. There are two branches statistical inference, namely estimation and testing of hypotheses. In estimation, we try to find an estimate of any population characteristic, while in testing of hypothesis, we try to test the statement about any population characteristic. Here in this session, our main concern is with testing of hypothesis. This is the basic fundamental questions and branches of statistical inference. Some basic definitions. What is population? Any collection of individuals under study is said to be population or universe. The individuals are often called the members or the units of the population, maybe physical objects or measurements expressed numerically or otherwise. What is a sample? A part or small section selected from the population is called a sample. Obviously, selected population should be representative of entire population, and process of such selection is called sampling. The fundamental object of sampling is to get as much information as possible of the whole universe by examining only a part of it. An attempt is thus made through sampling to give the maximum information about the parent universe with minimum effort. This is the fundamental object of sampling. In statistics, we get all information about the population from sample. What is the parameters? Statistical measurements such as mean, variance, etc. of the population are called parameters. And what is statistic? It is a statistical measure computed from sample observations alone. The theoretical distribution of statistics is called its sampling distribution. Standard deviation of the sampling distribution of a statistic is called standard error. Any questions? Can you understand? Mr. Ashish Shaha?
Yes, sir.
Any
No
problem
question.
for okay.
No, sir.
Mr. Borun Kumar Majhi?
Yes, sir.
Any question?
No, sir, till now.
Okay. What is the hypothesis? Hypothesis is a statement given by an individual. Very simple. Hypothesis is a statement given by an individual. Suppose I give a statement that the average height of these participants is 5 feet 5 inches. This is my hypothesis. Usually, it is required to make decisions about populations on the basis of sample information. In hypothesis, why it is needed? It is needed or required to make decisions about populations on the basis of sample information. I said that the average height of the participants is 5 feet 6 inches. Suppose number of participants be 100. It is not possible to take all the height measurements of all participants. So we take a sample size 20 or 30 or 10 and we get the measurements of that of individuals who are included in the sample. Now, on the basis of this sample information, my statement, that is my hypothesis, this the value average height of this group of participants is 5 feet 5 inches. We want to test my hypothesis is right or wrong. Such decisions are called statistical decisions. In attempting to reach decisions, it is often necessary to make assumption about population involved. Such assumptions, which are not necessarily true, are called statistical hypotheses. That is what is my statement is the average height of the population is 5 feet 6 inches. It may be wrong. This is called statistical hypothesis. What is parametric hypothesis? A statistical hypothesis which refers only to values of unknown parameters of population is usually called a parametric hypothesis. When question of hypothesis arises, automatically two words became. One is null hypothesis and another is alternative hypothesis. Any statement in testing of hypothesis, there are the two statements. One is null hypothesis and another is alternative hypothesis. A hypothesis which is tested under the assumption that it is true is called a null hypothesis and is denoted by H, not H suffix 0. Two statements are there, two hypotheses are there. When we assume these hypotheses may be true, then we called that hypothesis called a null hypothesis and is denoted by H naught. Thus, a hypothesis which is tested for possible rejection under the assumption that is true is known as null hypothesis. The hypothesis which differs here is said which is tested under the assumption that it is true is called a null hypothesis and is denoted by H naught. Thus, a hypothesis which is tested for possible rejection, we assume it may be true, but it may be possible rejection. Which hypotheses are the greater probability for rejection, then we call that hypothesis called null hypothesis. The hypothesis which differs the given null hypothesis H naught and is accepted when H naught is rejected is called an alternative hypothesis and is denoted. Sorry, my network connection may be disconnected me. Part you listen up to what? Can I say? Can you say?
Yes, sir.
What
Null hypothesis. Up to null hypothesis.
up to null hypothesis? Okay. H naught and is accepted, H naught is rejected, is called an alternative hypothesis and is denoted by H1. The hypothesis against which we test the null hypothesis is an alternative hypothesis. When null hypothesis will be rejected, automatically alternative hypothesis will be accepted. That hypothesis, which hypothesis against the null hypothesis, is called alternative hypothesis. Any question?
No, sir. Okay.
Simple and composite hypothesis. For null or alternative hypothesis, there are two types of hypothesis. One is simple hypothesis and another is composite hypothesis. A parametric hypothesis means hypothesis set for a parameter, value of parameter, theta, or suppose average, value of average, maybe mu, all like this. Parametric hypothesis, which describes a distribution completely, is called a simple hypothesis. That means which hypothesis gives the exact value of the unknown parameter, theta equal to 5 or mu equal to 5, like this, is called simple hypothesis. Otherwise, it is called composite hypothesis. So, in composite hypothesis, the distribution is not completely known. That is mu greater than 5 or mu less than 5 or mu not equal to 5. This do not gives the exact value of mu. So, that is called composite hypothesis. There are two types of hypothesis. One is simple hypothesis and another is composite hypothesis. For example, in case of a normal distribution, we know that there are two values, two parameters of normal, mu and sigma square. Mu equal to 5, sigma equal to 3 is simple hypothesis. Whereas mu equal to 5 is a composite hypothesis, because in this hypothesis, mu equal to 5 do not give any information about sigma, not exact information about sigma or exact statement about sigma. So this is called composite hypothesis. But in this hypothesis, mu equal to 5, sigma equal to 3 gives the complete information about mu and sigma. So it is called simple hypothesis. Whereas mu equal to 5 is a composite hypothesis, as nothing have been said about sigma. Similarly, mu less than 5, sigma equal to 3 is a composite hypothesis. Let H naught mu equal to 5 be the null hypothesis, is a simple hypothesis. Then there are three possibilities of alternative hypothesis. One is mu not equal to 5, that is two-sided composite hypothesis. Mu less than 5 is one-sided or left composite alternative hypothesis. Mu greater than 5 is one-sided or right composite alternative hypothesis. What is the test? Basically, we examine the hypothesis is true or wrong through a test. What is the test? Test is a rule. Test is a rule through we test the null hypothesis against the given alternative hypothesis. Basically, test is a rule through which we examine the null hypothesis is true or not against the given alternative hypothesis. In every cases or all time, we do not test, or we are not able to test a single hypothesis. In every time, we test null hypothesis against the alternative hypothesis. So it is necessary to state two hypotheses simultaneously. One is null and another is alternative. What is the test of significance? Procedure which enables us to decide on the basis of sample information whether to accept or reject the hypothesis, or to determine whether observed sampling results differ significantly from expected results, are called test of significance or test of hypothesis or rules of decisions. This is the definition, or this is the description of test of significance. Again we repeat, procedure. Test of significance is a procedure which enables us to decide on the basis of sample information whether to accept or reject the hypothesis, or to determine whether observed sampling results differ significantly from expected results, are called test of significance or rules of decisions or test of hypothesis. What is the level of significance? Because this is the statistical test or testing of hypothesis, is necessary to statement, accept or reject hypothesis with some probability. It is not deterministic decisions. For probability concept, it is necessary the decision may be wrong or may be right with some probability. So in testing problem or testing hypothesis, there is one question is, what is the level of significance? That is, what is the probability of accepting this hypothesis? The probability level of significance is the probability level below which we reject the hypothesis is called level of significance. The standard level of significance usually employed in testing hypotheses are 5% and 1%. 5% is the more used than 1%. So what is the level of significance? Level of significance is the probability level below which we reject the hypothesis is called level of significance. And level of significance usually employed in testing of hypotheses are 5% and 1%. Any question? Dr. Snehodip Chaudhary? Any question? Mr. Pralay Kundu, any question?
No, sir. Okay.
Okay. Understandable?
Yes, sir.
Now we come another definition. This is very, very important, and all practitioners out of statistics domain or statistics field all takes decisions on the basis of p-value. What is the p-value? The p-value is the level of marginal significance within a statistical hypothesis test representing the probability of the occurrence of a given event. The p-value is the level of marginal significance within a statistical hypothesis test representing the probability of the occurrence of a given event. The p-value is used as an alternative to rejection points to provide the smallest level of significance at which the null hypothesis would be rejected. This is a picture of null hypothesis. This is the p-value area. A p-value is used in hypothesis testing to help you support or reject the null hypothesis, to help you accept or reject the null hypothesis. The p-value is the evidence against a null hypothesis. The smaller the p-value, the stronger the evidence that you should reject the null hypothesis. This is the key line. The smaller the p-value, the stronger the evidence that you should reject the null hypothesis. P-values are expressed as decimals, so it may be easier to understand what they are if you convert them to a percentage. For example, a p-value is 0.0254, that is 2.54%. This means there is a 2.54% chance your result would be random, that is happened by chance. That is pretty teeny. On the other hand, a large p-value of 0.990% means your results have a 90% probability of being completely random and not due to anything in your experiment. Therefore, the smaller p-value is more important in your results. Actually, rule is if the p reject the null hypothesis at 5% level of significance. If the p-value is greater than 0.05, then we take decisions to accept the null hypothesis at 5% level of significance. Basically, we do a testing hypothesis, get the p-value. If we check if the value of p-value is greater than 0.05, then we accept the null hypothesis with 5% level of significance. Or if the value of p-value is less than 0.05, then we reject null hypothesis at 5% level of significance. This is the key line. Any question? Sunanda Mandal, any question?
No, sir.
No, sir. Sir, so p-value can
Ranged
never
or
be
not?
1. Sir, p-value can never be 1, right?
Not p-value, the value of p-value becomes 0 to 1, maybe 1. But it is
So when 1, it is totally random. The
exactly.
experiment.
That is not it is not possible in real life.
100%.
Theoretically,
That
the
is
value of
100%.
p-value is maybe 1.
That indicate 100%, sir.
Yeah,
Yeah, 1 means indicate 100%.
100%. That is 100% random. It is not possible in real life.
Okay, sir.
Another two concepts of testing hypothesis. What is critical region and acceptance region? A region corresponding to a statistic T. Obviously, a region means for whose region? Region of test statistic T is called the sample space. What is the range of T? The part of sample space which area of the sample
Sir, you are on the line? I think that connection again disconnected.
Yes, sir. Network problem, I think.
He will connect very soon. I am trying to connect to the resource person.
Okay, sir.
Please wait. This is the problem with the online system. I am trying, but he's not picking the phone. I don't know what happened. Something. Anyway, we have to wait a little bit. Call disconnected হয়ে যাচ্ছে. Anyway, we have in between that we will complete our other assignments. Okay, fine. As told earlier that you have to write a full day report. Okay, we can use this gap for the allocation of the or selection of the days where you are supposed to write report. Okay. So on first day, who will write the report?
Sir, have you assigned anyone or we have to select?
Just I started the process, not yet.
Okay.
Who will write the 20 seconds report? Nobody?
Sir, what are the
How-
things we
how much
need to
word
cover in
we have to
report?
Sorry?
how much
What are
word
the
we- how
things-
much we read?
Sir, Prolay sir, wait please. Yes, Ms.
Okay.
Dixit.
Sir, what are the things we need to cover in the report?
Okay. So, actually, a little bit of theoretical part, codings, what happened in the class, examples. Just you can write 3, 4, 5 pages. Fine.
Okay. Okay,
ठीक है.
sir.
Answer Prolay sir বলুন.
টপিকটা জিজ্ঞেস করছিলাম, আপনি তো বলে দিলেন 3 to 4 পেজেস।
ঠিক আছে, যে একটা মানুষ যেন পড়ে বুঝতে পারে যে ক্লাস সেশনে কি হলো। ঠিক আছে, ফাইন। সো প্রলয় স্যার আপনি নিচ্ছেন 22 তারিখটা?
যা বলবেন, যেটা অ্যাসাইন করবেন সবাইকেই তো পড়বে একটা।
হ্যাঁ, করতে তো হবে, রিপিট
যেটাই অ্যাসাইন করবেন কোনো অসুবিধা নেই।
তো ডক্টর প্রলয় কুন্ডুকে সরি অ্যাসাইনিং ডক্টর প্রলয় কুন্ডু for the 22nd February. Okay.
I have to submit the report within
48 hours after completion of the workshop.
48 hours after completion of the workshop. Okay.
Yes. So, sir is joining.
Okay, sir.
Yes, yes. Okay.
কতটা অবধি করিয়েছি কেউ বলতে পারবে? আমি তো বলে যাচ্ছিলাম।
আমি স্যার ফোন করছিলাম আপনাকে।
ও আচ্ছা 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 আচ্ছা, আমার ফোনটা আবার সাইলেন্সে ছিল।
হ্যাঁ না, ঠিক আছে, প্রায় 10 মিনিট হয়ে গেল। So participants, give the feedback please. আপনার স্ক্রিনটাও শেয়ার নেই কিন্তু।
হ্যাঁ, করে দিচ্ছি।
হ্যাঁ,
কালকেই প্রবলেমটা হয়নি, আজকে দেখছি হচ্ছে।
ঠিক আছে স্যার, সিস্টেম সেই জন্য তো 2.5 ঘন্টা হাতে রেখেছি।
হ্যাঁ হ্যাঁ হ্যাঁ।
ওকে স্যার, প্লিজ কন্টিনিউ।
হ্যাঁ, At what you hear? What?
পার্সেন্টেজ অফ এটা বলছিলেন স্যার।
To this?
নেক্সট পেজ স্যার। ইয়েস, ক্রিটিক্যাল রিজিয়ন।
Critical region. Okay. Okay. Repeat. What is the critical region and acceptance region? A region corresponding to its statistic T is called the sample space. The part of sample space which amounts to rejection of null hypothesis H naught is called critical region or region of rejection. That means actually the sample space of test statistics is called sample space, and part of that sample space which amounts to rejection of null hypothesis H naught is called critical region or region of rejection. If x1, x2, xn is a random vector observed and WC is the critical region which corresponds to the rejection of the hypothesis according to a prescribed test procedure of sample space W, then WA is equal to W minus WC of the sample space is called acceptance region. In whole sample space, one part is for critical region and another part is acceptance region. If x1, x2, xn is a random vector observed and WC is the critical region which corresponds the rejection of the hypothesis according to a prescribed test procedure of sample space, then WA equal to W minus WC of the sample space is called acceptance region. In statistical testing procedure, there are a probability attachment. So some errors will be arises. We take some decision, but it is not true in real life. May happen. So two types of error in testing a hypothesis. While testing a hypothesis H naught, the following four situations may arise. Audible? Am I audible?
Yes,
Yes,
sir.
sir.
Okay.
Yes, sir.
I checked some time after. The first situation, the test statistic may fall in the critical region even if H naught is true. Then we shall be lead to reject H naught when it is true. That means it is the wrong decision. Should be H naught is false, but it is not. Situation B, second situation. The test statistics may fall in acceptance region when H naught is true. We shall be lead to accept H naught. No problem. No error here. Third situation, the test statistics may fall in the critical region when H naught is true. That is H naught is not true. That is H1 is true. Then we shall be lead to reject H naught when H1 is true. It is perfect decision. Another situation and last situation, the test statistics may fall in the acceptance region even if H naught is not true. Then we shall be lead to accept H naught when it is not true. It is also a wrong decision or incorrect decision. There are no other situations out of these four situations. It is quite obvious that the decisions taken in B and C are correct, while the decisions taken in A and D are incorrect. So these two decisions arises some errors. Any question?
Yes, sir. We have studied like two type of error are in there in hypothesis
Ah,
type 1, type 2.
hmm.
So
I will
can you
come.
please brief
I will come. I will
accordingly?
come. I will come. I will come. This is the fourth situations. It arise in statistical hypothesis. The wrong decisions of rejecting a null hypothesis H naught when it is true, that is situation A, is called the type 1 error. That is, we reject H naught when it is true. Similarly, other wrong decision of accepting the null hypothesis H naught when it is not true is called type 2 error. That is, we accept H naught when H1 is true. Okay? Type 1 error is the error when we reject H naught when it is true. And type 2 error is the error when we take decision to accept the null hypothesis H naught when it is not true. So the probability of type 1 error, that is probability of reject H naught when H naught is true, is called alpha. And probability of type 2 error, that is probability of accept H naught when it is wrong, is called beta. The alpha and beta are called the size of type 1 error and size of type 2 error respectively. That testing problem is good where type 1 error and type 2 error are all at minimum level, but we do not minimize these two errors simultaneously. It is not possible. So we make a standard level of one error at a standard level. After that, we try to minimize other error. It is the process of minimization of error in testing of hypothesis. The rules or procedure for testing of hypothesis. A test is a statistical procedure or a rule for deciding whether to accept or reject the hypothesis on the basis of sample values obtained. Am I audible?
Yes, sir.
Following is the procedure for testing of hypothesis. There are 5 steps. First step, mention the null hypothesis H naught to be tested along with an alternative hypothesis H1. This is the first job. And second step is make some assumptions such as the sample is random, the population is normal, the variance of two different populations are equal or unknown, etc. This is an example of normal distribution. Third step, then find the most appropriate test statistic together with its sampling distribution. A statistics whose primary role is that of providing a test of some hypothesis is called a test statistic. Fourth step is on the basis of sampling distribution, make a decision to either accept or reject the null hypothesis H naught. And last step, take a random sample and compute the test statistic. If the calculated value of the test statistic falls in the acceptance region, then accept the null hypothesis H naught. If it falls in the region of rejection or critical region, reject the null hypothesis H naught. Have any question? Have any question?
No, sir.
Okay. Not need this part. Now we come to the parametric and non-parametric test. Up to the last slide, this is the general part of statistical hypothesis. There are two broad areas of testing of hypothesis. One is parametric and another is non-parametric test. In the literal meaning of the terms, a parametric statistical test is one that makes assumptions about the parameter of the population distributions from which one's data are drawn, while a non-parametric test is one that makes no such assumptions. Actually, when we know the sampling distribution or sampling law of a characteristic under study, we do not know the value of the parameter, but we know the law, that is normal distribution or binomial distribution or Poisson distribution like this. Then it is called parametric test. When we do not know the distribution, then it is called non-parametric test. Non-parametric test is more useful than parametric test, but big but here, when we already know the distribution, then parametric test is more powerful than non-parametric test. So anybody ask me that, so always we can, why we do not use the non-parametric test? We can, but when we know the distribution of the population, then parametric test is more powerful than non-parametric test. So when we know the distributional assumption or we know the distribution of population, then we go to the parametric test. When we do not have this, then we go to the non-parametric test. Okay, am I audible?
Yes, sir.
Yes, sir.
Yes, sir.
I take 10 minutes break right now. Okay,
Okay, sir.
after 10 minutes I will join.
So we can continue with our earlier assignment. So Rajiv Bora sir is already taking the session of 23rd February, Dr. Arindom Gupta. So Professor Athar Ali Khan on 23rd, first session, who is going to take? Okay. Ashish Shah, fine? Are you attending?
Yes, sir. Yes, sir.
Okay. বুঝলে আমি কি
Sir, don't hear you. Please repeat.
3rd February ফার্স্ট সেশন অর্থাৎ প্রফেসর আথার আলী খানের যে লেকচারটা হয়েছে তার ডিটেইল রিপোর্ট আপনাকে লিখে দিতে হবে, ঠিক আছে?
স্যার ওটা আমি লিখবো?
ইয়েস, আমি
ওকে ওকে ওকে।
আসলে প্রবলেমটা কি জানেন তো, আমি কমিউনিকেট করছি, আপনারা কখন থাকেন না বোঝা মুশকিল হয়ে যায়, সেই জন্যই প্রবলেম হয়ে যাচ্ছে যে হাফ কমিউনিকেশন হয়ে যাচ্ছে। কারণ এখন সিস্টেম একটু সবকিছু পাল্টে গেছে, সার্টিফিকেশনের সঙ্গে আমাদের একটা রিপোর্ট জমা দিতে হয়, সেই জন্যই এই ইস্যুস গুলো উঠে আসে। এনিওয়ে আপনাকে লিখে দিতে হবে, ফাইন। ওকে, রাজীব বোরা স্যার হয়ে গেছে। 24th February আজকের সেশনের উপরে কে লিখবে? who will write? কাজল ভারতী?
No, sir, no.
No?
Not
No?
today's section. No, not today's session, especially Sir Professor Athar Ali Khan, sir. Actually, those formulas are not related to my subject.
Okay,
So I
okay.
would, yes,
I understand. So, okay, I will give later on. Okay, I understand. So,
sir, I can write. Yes, sir. I was going to say, I can do it for the morning session, today's morning session.
Okay. आज सेकेंड हाफ में आप लीजिए अरिंदम सर का.
So I can take that.
Oh, okay. You are comfortable with this?
Yes, sir. Yes, sir.
ठीक है.
Okay.
काजल भारती. Okay. So till now is fine. Then I will allocate others.
Sir, Arthur Khan has shared the document with you?
No, still not. But I will try to collect him.
Yes, sir. I would need the document to make the report. Otherwise, it is not possible to make the report. So,
Okay,
yes.
I will try. I have to give some few days to Professor Khan.
Okay, sir.
Actually, he's just too much busy with the administration. That's the problem. Good teachers are on the administrative chair, and your universities are already started their examination. Anyway.
There, sir.
Yes, please.
Tamang sir share the PPTs also.
No,
he sent
no.
HTML program, HTML file only.
No, whatever he has given, I circulated then and there. No additional things are given to me. আমাকে যে যা দেয় আমি সঙ্গে সঙ্গে শেয়ার করে দিই.
Okay, sir.
Okay. So tomorrow I will send a data in the late evening, and on that data there will be practice tomorrow. Okay, so all the participants are the resource person. All of you are the resource person and simultaneously participants. Those who are not able to understand, others will help you, and one person will help you surely. He will give the data tonight. I will give you for the next 2 days, in the first 25th and 26th first session. Okay, in the
Okay,
second. Okay, I will.
There, sir.
একটু ওয়েট করুন, আমি ফোনে কথা বলছি. হ্যাঁ.
Okay.
হ্যাঁ স্যার বলুন.
বলছি যেহেতু আমাকে প্রথম দিনেরটা লিখতে হবে, অফিসিয়ালি লেট মি নো টোটাল নাম্বার অফ রেজিস্টার্ড পার্টিসিপেন্ট অ্যান্ড অ্যাকচুয়াল নাম্বার অফ পার্টিসিপেন্ট, এই দুটো ইনফরমেশন একটু আমাকে শেয়ার করতে হবে.
আপনার 24 জন আছে
রেজিস্টার্ড,
ঠিক আছে, 18 জন অ্যাটেন্ড করছে,
18,
24
among different state or
different
particular?
state, না
Okay.
particular state নেই, throughout the country.
Thank you, sir.
So just I call the person, he will give the detail. I will share tomorrow. They will conduct practice on time series, okay, which is not in the schedule. That will be helpful. अच्छा दीक्षित जी,
Yes, sir.
आप बताइए, मेरे हिंदी में बंगाली का एसेंट आ रहा है क्या, कि पूरा क्लियर हिंदी में चल रहा है, बोल रहा हूँ?
सर अभी तो क्लियर है।
चलिए बढ़िया है, मैं अपने को टेस्ट कर रहा था कि कहीं हिंदी भूल न जाऊं।
नहीं सर, अच्छा है।
चलिए
जी।
Am I audible?
Yes, sir.
Yes, sir.
See you presentation.
Okay, sir.
Now, what is the parametric test? Most of the statistical tests we perform are based on a set of assumptions. When these assumptions are violated, the results of the analysis can be misleading or completely erroneous. Typical assumptions are normality. Data have a normal distribution, or at least is symmetric. There are many parametric tests without normality assumption also. Homogeneity of variances, linearity, and independence. These are 4 common assumptions, but violation of these assumptions also we have parametric tests. We explore in detail what it means for data to be normally distributed in normal distribution. But in general, it means that the graph of the data has the shape of a belled curve. Such data is symmetric around its mean and has kurtosis equal to 0. In testing for normality and symmetry, we provide tests to determine whether data meets this assumption or not. Some tests, example ANOVA, we know the name ANOVA, we require that the groups of data being studied have the same variances. In homogeneity of variances, we provide some tests for determining whether group of data have the same variance or not. And some tests, example regression, require that there be a linear correlation between dependent and independent variables. Generally, linearity can be tested graphically using scatter diagrams or via other techniques explored in correlation regression, multiple regression. This is the standard normal curve. Many statistical techniques assume the data fits a normal distribution. Many statistical methods require that the numeric variables we are working with have an approximate normal distribution. Standardized normal distribution with empirical rule percentage. For example, t-tests, f-tests, and regression analysis all require in some sense that the numerical variables are approximately normally distributed. First we came t-test. What is the t-test? The t-test is a basic test that is limited to two groups. For multiple groups, we would have to compare each pair of groups. For example, with 3 groups, there would be 3 tests, AB, AC, BC. Whilst with 7 groups, there would be need to 21 tests. The basic principle is to test the null hypothesis, that means of the two groups, means of two groups are equal. In t-test, we do the testing of the means of two groups are equal or not. The t-test assume normal distribution, underlying variances are equal. If not, use Wells test. It is used when there is random assignment on only 2 sets of measurements to compare. There are 2 main types of t-test: independent measure t-test when samples are not matched, and paired t-test when samples appear in pairs. A single sample t-test compares a sample against a known figure. For example, when measures of manufactured item compared against the required standard. Application where we apply the t-test to compare the mean of a sample with population mean. This is called simple t-test. To compare the mean of one sample with an independent sample t-test. To compare between the values of one sample but in 2 occasions, that is called paired t-test. What is the 2 sample t-test? The independent samples t-test or 2 sample t-test is probably the single most widely used test in statistics. It is used to compare differences between separate groups. Am I audible?
Yes, sir.
Yes, sir.
In psychology, these groups are often composed by randomly assigning research participants to conditions. However, these tests can also be used to explore differences in naturally occurring groups. For example, we may be interested in difference of emotional intelligence between males and females. Any difference between groups can be explored with the independent t-test or 2 sample t-test, as long as the tested members of each group are reasonably representative of the population. There are some technical requirements as well. Principally, each variable must come from a normal distribution. This is the basic assumption of t-test. We consider an example here. We organize the tests. First, where we use this test, what is the test, and one is real life example. Suppose we put people on 2 diets, the pizza diet and the beer diet. Participants are randomly assigned to either 1 week of eating exclusively pizza or 1 week of exclusive drinking beer. Of course, this would be unethical because pizza and beer should always be consumed together. But this is just an example. At the end of the week, we measure weight gain by each participant. Which diet causes more weight gain? This is our question. In other words, the null hypothesis is H0, weight gain pizza diet, equal to weight gain beer diet. The null hypothesis is the opposite of what we hope to find. In this case, our research hypothesis is that there are differences between 2 diets. Therefore, our null hypothesis is that there are no difference between these two diets. These are the data. This is the test statistic. In software, but in R, we do not need to calculate these values. In this, we calculate in hand. After calculating p-value, we need to know if it is large enough to reject null hypothesis. The t is calculated under the assumption called the null hypothesis that there are no difference between the pizza and beer diet. If these were true, when we repeatedly sample 10 people from the population and put them in our two diets, most often we would calculate of t of 0. The calculated t value is 4.47. Calculated t value is 4.47. Notice I have eliminated the unnecessary minus sign. And the degrees of freedom are 8. In the research question, we did not specify which diet should cause more weight gain. Therefore, this t-test is so-called two-tailed t. In the last step, we need to find a critical value for a two-tailed t with degrees of freedom, 8 degrees of freedom. But it is not necessary when we do this test through R software. So now we go to the R. Just a minute. What is the function for t-test? I remember this is the t-test. No. What is the t-test? We go to the Google. What is the exact test?
Sir, your screen is not visible.
Now it is shown.
Yes, sir.
Okay. Google.
Yes, sir.
Type t-test R. What is the t-test function? T.test. T.test. Okay. T.test. Then we go to the R. See the documentation? This is the documentation of t-test, students t-test. The function is t-test and package is stats. Perform 1 and 2 sample t-test on vectors of data. T.test within bracket arguments. X is a numeric vector of data values. Y is the an optional main vector, numeric vector of data values. When we use 2 sample t-test, then we need X and Y both. But when we need only X, only simple 1 t-test, then we need only X. Suppose t-test data new script Suppose the one data is 1 to 10, x is 1 to 10, and y is c to 20. Then we want to test x, mean of x equal to mean of y or not. Control R. This is the output of two sample t-test. Is it visible?
Yes, sir.
Okay. See, the calculated value of t is this, degrees of freedom is this, and this is p-value. It is very important. We take the decision on the basis of the value of p-value. Here, p-value is 1.855 into 10 to the power minus 5. That is, the value of p is 0.40, then 1855. So it is less than 0.05. So we reject the null hypothesis. Here null hypothesis is the mean of x equal to mean of y, and against mean of x not equal to mean of y. So we reject the null hypothesis in this case. Basically, suppose x is equal to sequence 10 to 15. X data is this. Sorry. No. X is equal to, suppose I put the data to keyboard.
Sir, you forget screen.
Okay. Oh. Okay, this is the x values, and y values are maybe may not be same number. Now we test t dot test is equal to x comma y. This is the p-value. Here p-value is 0.8224, that is greater than 0.05. So we accept the null hypothesis, that is the mean of x and mean of y be same, statistically be same at 5% level of significance. Last data, in last part, output part, here it is the mean of x and it is the mean of y. Maybe you say that the mean of x is different from mean of y. So we want to test the mean of x equal to mean of y. And you say through p-value that the hypothesis, null hypothesis is accepted. That means mean of x equal to mean of y. But here the data mean of x is different from mean of y. May happen. Why? You conclude this decision p-value less greater than 0.05. This is for population, and these values for sample value. So, but the closeness is very near. If we take another data set, y equal to c within bracket 1, 2, 3, 5. This is y. Then we want to test t-test x comma y. Then p-value is 0.1237. It is also accepted. Another data, suppose 0.1, 0.2, 0.3, 0.4, 0.5. Now test p-value is 0.34, less than 0.05. So we reject null hypothesis. The difference is more mean of x and mean of y. Any question?
Yes, sir.
Here, degrees of freedom. What indicates the degree of freedom?
That is the more depth question. It is not possible to understand what is the degrees of freedom out of the statistics domain people. Okay, you do not need. We just need the check the value of p, and where you apply which test, it is your jurisdiction, but not in detailed statistical analysis part or calculation part.
Okay, sir.
Sir, like in SPSS, we usually have tables, and we put that table in our research papers.
But in
how
R
will,
it is not possible.
so how will
R
we
it is
present it in our research paper? Like
you
this only?
can copy. You can
Okay.
copy. You can copy, but not in SPSS format.
Okay, thank you.
So what is the conclusion? The calculated t value is larger than magnitude. P value is here. Null hypothesis is rejected or accepted. Just a minute. Reject the null hypothesis. That means the p value of this test is less than 0.05. Ultimate decision is participants on BR diet gained significantly more weight than those on pizza diet. Okay, this is the actual interpretation of the result. One is chi-square as a statistical test. F test. We send this presentation to you for your further reading. ANOVA problem, regression problem, jet test, all have the R functions. Choosing between parametric and non-parametric test. When you choose the parametric test, when you choose the non-parametric test. Deciding whether to use a parametric or non-parametric test depends on the normality of the data that you are working with. Therefore, the first step in making this decision is to check normality. One option is to perform a simple check based on a histogram. Histogram is simply a frequency plot. We already know if your histogram is roughly symmetrical, it is safe to assume that the data is relatively normally distributed and a parametric test will be appropriate. If the histogram is not symmetrical, then a non-parametric test will be more appropriate. It should be noted that the checking normality of data produced by smaller samples can be difficult. Sometimes with a small sample, data displayed in histogram will be obviously asymmetrical. But there are certainly occasions in which it is impossible to tell. This is because with a small sample, the histogram may not be smooth even if the data are normal. There might not be any significant evidence of symmetry or asymmetry, which can make it difficult to determine whether data are normal or not. However, one way to get around this obstacle is to leverage instance in which the same measurements have been measured from a previous larger sample in an earlier study. If the data is found to be normal in previous studies using larger samples, it is safe to assume your data will be normal as well. If your data is not normal, there are steps you can take. If your data is not normal, there are a few steps you can take prior to performing a non-parametric test. Okay. If your data is normal, use a parametric test, t-test, ANOVA, appropriate, regression analysis, correlation coefficient, like. If data is not normal, using a non-parametric test, one sample sign test, one sample Wilcoxon sign rank test, Mann-Whitney test, Spearman rank correlation, many tests are there. This is the unconsolidated chart. Categorical variable, manually U test, non-parametric test, parametric test, independent test, and this you can check. Non-parametric statistic, run test, Wilcoxon sign rank test, Kruskal-Wallis test. Okay. Any question? We'll stop here our presentation. I sent this to you, Daya sir, to send you directly.